All right, so let's take a look at these practice problems from Skill 8F. In 8F, we were presented identities, the reciprocal identities, the quotient identities, and the Pythagorean identities, and there's three of each. And so, again, later on in Skill Packet 12, we revisit verifying to proving various trig identities. Uh, right now in this problem number one, it's wanting us to verify a reciprocal identity. It's saying that it wants us to show that the cosine of theta is equal to 1 over secant theta. Now this other information is just kind of information to remind you of some definitions and some things that you'll likely use in verifying and showing that this equation is a true statement, including our definitions of all six trig ratios of how we defined it with respect to angle theta in this first quadrant, and that from the Pythagorean theorem that x squared plus y squared is equal to r squared. R is a distance and r is always greater than 0. So let's jump in, and we can either pick the right hand side or the left hand side to try to manipulate it to look like the other side. So I'll do this problem both ways. Suppose that you started with the right hand side of the equation, and you said, hey, I'm going to show that the cosine of theta is equal to 1 over the secant of theta by first using the definition of cosine, that the cosine is defined to be the adjacent leg over the hypotenuse, which is x over r. And so now let's think about what this is. Let's multiply by the number 1. 1 times x over r isn't going to change that. And I can rewrite this multiplication of multiplying x over r. I can change that to division if I take the reciprocal of x over r. So I could write that as r over x. I know that r over x is that ratio is defined to be the secant. So I have 1 divided by the secant of theta. That's what this is reminding me here, that when you see this ratio of r over x, it is equivalent. It is the same thing. It is equal to. It's the same thing as secant theta. So where I see r over x, I can replace it with secant theta. We typically will write division as a fraction. And here we have shown that the left-hand side cosine of theta, through these definitions and these substitutions and using properties of arithmetic, we have shown that the cosine of theta is equal to 1 over the secant of theta. Okay, so what if somebody had, instead of starting, look, I said right hand side, this is my left, gosh. So this was this was the left hand side of the equation. All right, I started with that left-hand side, and I illustrated that it was equal to the right-hand side of the equation, right? All right. So let's start with the right-hand side and see if people could have done it there. And probably, if given the choice, I would have picked the right-hand side because it appears to be more complicated than the left-hand side. And in general, later on when we really get into these, it's usually easiest to simplify something. So if I start with the right hand side, and I'm trying to illustrate that this right hand side, which is 1 over the secant of theta, I'm trying to illustrate that that's going to equal the cosine of theta. So I'm going to start out by saying, well, what do I know about secant theta? I know the definition of what secant theta is, that everywhere I see a secant theta, I can replace it with this ratio r divided by x. So I have this complex fraction, a fraction within a fraction, and sometimes students remember it a little bit better if you write it with the division symbol instead of a fraction bar, that we have 1 divided by the fraction r over x, and that we can change this division to multiplication if we take the reciprocal of the divisor, if we flip this r over x. And now 1 times x over r, well, that's obviously x over r. And now, you know, the reason that we gave you that x over r is equal to cosine theta is just to remind you that, hey, you're done. Now we have shown that the right-hand side is equal to the left-hand side. So we're pretty confident in saying that, yes, this identity is a true statement. Hope that helps.